would like to say. We have been marketing, distributing, selling, providing technical support for the Duratec, Aqua-Buff, Styrosafe lines of products all over the world for those 40 years, almost 41 now. And as you can see up on the screen, we service and support a variety of different industries. So pretty much anywhere where the composites world touches or interfaces, you'll find Duratec, Aqua-Buff, Styrosafe in some way, shape, or form. So we're going to talk a little bit about some of those industries today and the way that our products engage in those. But I will say that we have a sales webinar that's up on our website, and we'll show you all those resources soon. But it's up on our website, and it talks more in depth about products specific to industry. So if you're here on this call today and you're getting some good information on how to troubleshoot, but maybe you have a new project and you'd like to know what product would be best suited, we're resources, of course, and then that webinar is there along with several others. So as I mentioned, we've got Duratec, Aqua-Buff, Styrosafe. Jody, Rob, and I are responsible for making sure that you guys feel supported, whether you're an end-use customer or one of our distribution reps, or possibly one of our colleagues here on this call, to make sure that you feel wholly supported, both in selecting your product, but then also being able to apply it in a smooth, calm, satisfactory process. So I mentioned his name before. Serving us based out of Florida is Rob Smothers. Rob is our Southeastern technical sales manager. Hello, Rob.
Good afternoon, everybody.
Jumping clear over to the other coast, almost diagonally to the other side of the US, we have Jody Wise. Jody, based out of Washington State, serves the Western United States as our West Technical Regional Sales Manager. Hello, Jody.
Hello, I'm glad to have everybody here today. Thank you.
And if you happen to be centrally based or in the Northeast, and I should have mentioned, Jody also covers Canada as well, the Western provinces of Canada. If you're in the central or Northeastern US or the central Northeastern Canada, I am your technical service rep. I also cover our international distribution partners and customers. So if you're joining us not from here in North America, welcome. Thank you for committing to that schedule. Those are some very different hours. So we're glad that you're here with us. And I'm your point of contact if you have questions after this. At the very end, we'll have everybody's contact information up. Obviously, there's three of us. We work with a tremendous amount of support from our distribution partners, and we'll put up our website at the end of the webinar, and you can find all of our distribution partners. And those sales reps that work for the distribution partners are well-versed in our products. If you're joining us and you happen to be one of our distribution reps, hello, thanks for joining in. They know how to find us. They know how to call us and have us come in and meet with you. So we are here as your resources, and so are the distribution partners as well. All right, so we're here to talk about troubleshooting. We're here to talk about specifically troubleshooting the Duratec, Aqua-Buff, and Styrosafe product lines. So a brief look at our agenda, just so that you have an idea of how we're going to flow through this. There is a lot of information, and we want to give you as much as possible. We generally try to stick to about an hour, usually leaving extra time at the end if we need it, for anybody that wants to stay around and has additional questions. But we're going to talk about, first up, the 5 most common issues that we see. Those are kind of non-product specific. They're the questions that our customer service team hears about all the time. They're perhaps the ones that we spend the bulk of our time talking about on an initial basis, especially as someone is becoming familiar, usually with the Duratec line of products. And then what we decided to do is we are going to compartmentalize the next troubleshooting steps or troubleshooting issues and their solutions. And we're going to go by product families. So we'll talk about the Duratec sealers, putties, primers, top coats, the Aqua-Buff, and then we'll kind of open it up to questions. We'll open it up to stories and kind of the Wild West, as Allie's put it here, wild experiences that we've had, because every once in a while something new comes up and it's something that you are trying to solve and something that we haven't seen before, and we're trying to help you troubleshoot and solve as well. And then at the end, we'll kind of go through what additional solutions there are to help you figure out both in the moment, and then also, as you're getting ready to do a project, what you want to do in advance. So we'll talk about some of those solutions and resources as well. And as I mentioned at the end, we will have open question and answer. So we have 2 ways that you can connect with us on the Zoom call. One is through the question and answer box, which should be an option kind of down towards the bottom of your screen. And the other is the chat function. Both of those are public, so everyone, you can opt to message us privately, but otherwise they're public and everybody will get to see those. If it is a question that I know, because I'm going to watch them, if it's a question that I know we're going to answer, then in the course of our slides, then I kind of hold off on that. If we don't get around to it, I leave it open, and then during our main Q&A session, we'll make sure to address it there. Don't be shy. This is what we're here for. So while we have an agenda, we certainly want and welcome your questions and hope you'll pop those in there. So I think I've covered all of the things that we need to do. I've mentioned these product families before, these product lines before. Duratec is our surfacing technology product. So it's the sealers, primers, putties, top coats. We'll talk about those. Aqua-Buff is our compound and polishing line, and Styrosafe is an EPS friendly both resin and primer system for being able to use EPS in your processes. So again, we're going to talk about all of those product lines through these little bits and pieces. But first, we're going to kick off with the not so fab 5 common issues. And Jody, Rob, we hear about these very often, don't we?
Pretty much
Yes.
every day.
Pretty much every day. All right. So Rob, kick us off with the first one. What is it and what do we do about it?
Okay. Well, one of the main common ones that we have out there is orange peel. Name is pretty much self-explanatory. You get a finish on your primer, your top coats, gel coats, tooling, whichever product you're spraying. It looks like the skin of an orange. The range of orange peel depends on certain things. So you can have a severe orange peel, you can have a minor orange peel. It all depends on how the material is being applied. It depends on the air pressures that you've got on your equipment. It depends on the atomizing pressure that you've got on your equipment. It could be the viscosity of the material. It could be the age of the material. It could be your tip size. It could be how the film actually levels off. So there's multiple reasons that create orange peel. It's virtually impossible to spray a complete part and not see even minimal orange peel. So, but there are ways to fix that, and there are ways to repair that. Is you put a leveling agent in your material, a thinner that goes into your material that we carry, and it will help level it off. You adjust your air pressures, you adjust your atomizing pressure. You may have to change tip size. We want to see the material flow onto the part that you're trying to spray. We really don't want to see it impacting it if your atomizing air is off or if your tip size is too small. So there's things that you got to play with it until you find it. Most of you guys that have been doing this for a while, you understand the techniques. You understand that you've got to arrange your pressures, your tips, everything else to get it to where it optimizes what you're trying to accomplish. And then again, it comes down to once that part is completely cured, you're going to have to go back there and sand it, whether you're sanding it with 150 grit or it's minimal enough because you did a great job spraying it and you can go right to a 400 grit, sand it down smooth. If it's on a primer, once you get it smooth and complete, you're ready for your next step, which is however you're finishing your part. It might be a top coat for a mold. It might be gel coat because you just sprayed a side of a hull or a deck or even an automotive part, and then you're ready to go.
So Rob, I noticed on our picture that we have kind of the gradients as we're moving down. And for those of you that might be on a smaller screen, even for those of us that are on a larger screen and still need our glasses, just know that when this is completed, when the webinar is completed, this will come out as a link to the video and you can pause it and kind of zoom in. Sometimes it's hard to see the images on the screen, but on this rub, I'm seeing kind of a gradient. So this is moving from a severe orange peel down to a flat surface. Yeah. Okay.
Down to where you've sanded, buffed it, and ready for your next application.
Okay. Excellent. So the second one that we see very commonly, again, kind of across our product lines, across our product groupings, is fish eyes. And this one, we've got the lights from above to kind of help us see this. Fish eyes look almost exactly like what they're named after. Fish eyes, they're little teeny divots. We've had folks, reference them as volcanoes because they kind of feel like everything kind of runs down into them, but they're little teeny holes that appear on the surface. And we see these primarily in our top coats. They can happen in our primers, but we see them primarily in our top coats. And oftentimes what we have found is that, kind of like Rob said before with the orange peel, sometimes it's just a viscosity issue. And so, maybe that viscosity requires that you change out your tip size so that you can atomize a little bit differently, so you can put material down on the surface differently. Sometimes that viscosity means that it's struggling to get surface tension on whatever surface you're spraying. So if you're spraying it onto a mold surface that's been prepped, particularly with a semi-perm mold release, we will see these periodically because the top coat is struggling to find its flow across the surface and it's forming these fish eyes. That is usually accommodated or solved by adding a layer or two of paste wax, and that paste wax will allow that surface tension or that the material to hold the surface tension and level and flow instead of creating the fish eyes. It's just pulling away from each other. The perhaps most common reason that we see fish eyes is from some sort of contamination. And this is a challenging one because contamination can show up pretty much anywhere. So it could be oil or water in your line. It could be something from within the atmosphere around you, whether that's dust particles from sanding, whether it's someone is spraying something with silicone 50 feet away and just it's happening to catch the breeze. Maybe your parts are stored outside or your substrates are stored outside, and when you bring them in, there's some sort of surface contaminant. That is generally where we see fish eyes. And the solution for that is a little tricky because you've got to do a little Sherlock Holmes style investigation to figure out where it can be coming from. And it's not always clear and it's not always consistent. We've seen folks where it fish eyes in one specific area, but nowhere else. Sometimes that's because they're spraying too thin or too heavy in that particular area, or that area is exposed to something that the rest of the part is not exposed to, or the rest of the mold is not exposed to. So with fish eyes, we generally start with contamination. If you call us, that's oftentimes the starting point that we'll start. We'll want to try to eliminate where there might be avenues of contamination coming in to your shop. But it could also be a surface tension issue remedied by paste wax. So that's fish eyes. Jody, the next one kind of gets confused for fish eyes periodically. What's this one?
Well, porosity, and it can be a nightmare for anybody doing tooling, especially because you've worked so hard to make this plug, and you've gel coated your tool and laid it all up, and now a month later you're demolding this thing and you go to polish it and buff it and it's got porosity in it. Not what you want to see. Now, there's several reasons for it. Some that are easy to rectify is putting on too much material too fast. You can get sags. You can induce air into it with too much material at one time, and it can't escape. A couple other things: the air pressures. If your air pressure is too high at times, you might get some porosity in the finish. If it's too low, you may get some larger porosity in the finish. There's two routes to porosity on atomization air. So you kind of have to balance it out. And you want the material to be a nice, even film on the surface so it can all flow together. This helps with, it helps with porosity for the same reason that it helps with orange peel, is because it allows the material to move on the surface and allows the air to escape. If you spray it too dry and you get a popcorny finish on the surface, then the air can't escape. It just gets trapped. Now, another one is catalyst types. If you're using, especially a vinyl ester, they're sensitive. All vinyl esters foam quite a bit. And when it's used in a pressure pot or a gravity feed gun, it's not quite as the same issue it is as it is if it's used in a regular large airless piece of equipment where you've got external catalyst mix or even internal in the gun catalyst mix. And part of that is because the whole chemical reaction is taking place on the surface of the part you're spraying it on. Whether you're refinishing something or spraying it for the first time in mold, all that chemical reaction and all of the foaming that takes place is immediate right on the surface, and it can't always escape. In a gravity feed gun or a pressure pot, you're drying off the bottom of the container, so any foaming, that material goes to the surface, and it takes a little while for you to actually empty the container. So it's had time to react, foam, and release the air, but that's not what happens with an external mix or internal mix airless system. So that's where you might want to switch to a totally different type of catalyst, CHP. It won't foam at all. So if you're really want to be safe and porosity is an issue, CHP catalyst can virtually solve that. The other nice part about it is it gives you more working time. It will extend the gel time almost double, which if you're spraying with a pressure pot or gravity feed might be a great opportunity to do a better job of spraying and not just worrying about it getting out of the gun in warm weather.
Thank you, Jody. All right, Rob, what about delamination?
Delamination. We do get a lot of calls on this. And there are multiple reasons that can cause delamination. A big part of that is you're getting moisture that migrates into the laminate between the layers. So you're not getting the correct bond that you should be getting from one substrate to the film that you're putting over the top. And it creates a barrier. You see this once it cures, you may see it start to lift up and peel a little bit. We get a lot of calls sometimes that customer may not see this until he actually goes to buff that part, generates a lot of heat on that part, and all of a sudden his film is just completely flying off the part. So there's different levels of when the delamination can happen. Some of the reasons too is all that it's spraying on a part with excessive heat, and that material is curing a little bit faster than it should, doesn't have time to lay down or doesn't have the proper time to actually bite into and bond to the substrate that's underneath it. Once you get the material sprayed, if those parts get moved too soon, you start to flex those parts. That can cause some delamination. You're stressing the surface of that part. Surface impact. It gets bumped around, it gets banged a little bit. Once it's cured, that can also create a delamination. So, and it's just a poor bond between the layers. That could be caused by the wrong solvent mixture being in there. Sometimes it creates cracking. The material could be too thick. There's all kinds of reasons that cause that. And then we can get into how to resolve that. Is basically you've got to come back, you've got to sand that area down, peel it back as far as you can go till you get to where it's really bonded down to your part. You want to feather that around in there, and then you're going to have to probably come back and I would say apply an actual sealer to that part. Once that is dried and cured, then you come back and spray your primer right back down over the top, and then come back, sand it down pretty smooth, and then you should have the problem, the delamination fixed, ready to move on to your next step.
Wonderful, thank you. So I have to just pause real quick, Jody, before I have you talk about alligatoring. My son and I were doing a project in the garage the other day and we saw this. that we experienced this alligatoring happen, and he told me that it has great aesthetic. So none of us want to see this happen, but evidently to the youth of today, it has great aesthetics. So I thought that
If
was
you really tried to make it happen, you probably couldn't, and it wouldn't be uniform. So,
right,
and
right. And that is exactly the truth. Yep.
I made this panel, and what I did to make this panel was start on one side with very thin gel coat from almost nothing. And then on the other side of the panel, it goes up to 20 mils. And somewhere in the middle, you can see a line. That line is not a separate spray job. That is just as I sprayed over that thin, not fully cured gel coat first layer, that's the point at which it transitioned into cured well enough to not alligator. So what I'm going to say is there's only one reason that there's alligation, and that's because the first layer is not thoroughly cured when the second layer is sprayed over it. Now, there can be 100 reasons why it's not thoroughly cured. You could have sprayed it too thin, not enough catalyst, you didn't wait too long, it's too cold, various reasons. But that's it's that it isn't fully cured. The styrene solvents, things in the second layer attack the first layer, and because it's not fully cured, it wrinkles up like this. So that's the reason. If you're getting this, and 90% of the part doesn't have it, but you have areas that do, it's typically because either there's styrene fumes lingering in those areas and you need to put a fan on it if they're low spots, or those areas are a little bit more difficult to spray and it's just thinner right there. And you should come back and brush some material on, spray more on the first time, a few things like that. Now, I will say, in some situations, it pays to mix a little bit of aerosol into gel coat if you've got some thin spots on the mold that you think might gator if you brush some gel coat on them. You can put a little bit of aerosol in the gel coat and thicken it up slightly. And then I'll typically use a plastic spreader to skim over those areas where you can see the mold. Because what happens is, the solvents in it there's not enough solvent left after it wets out the surface of all of the aerosol you've put in, so it doesn't attack that thin area as much. That's one thing you can do. If you just brush gel coat over it, it might alligate, but if you add a little aerosol, that likelihood goes down. The bad side of that is because those solvents and the resin is used to wet out the aerosol, it may not bite as well into the gel coat. So there's a good and a bad. Neither of those really show up often. It's just, I want to warn people, if they're using this below the water line or something like that, you make extra effort to do it right. If it's above the water line, it's not going to make much of a difference.
So Jody, I'm just going to pause us here for a second because you mentioned gel coat, and I feel like we see this as a troubleshooting issue, Rob, from your perspective as well. We see this far more often in the gel coat world than we do with any of the Duratec products.
We do.
Yeah.
It's one of those things, our products get used in a little different way, and they're not quite as susceptible to alligatoring because all of the Duratec products surface cure, and they will cure very well in a thin film, whereas gel coat doesn't cure well in a thin film. So I'm guessing this is someplace around 10 mils on that line there where it starts to alligate. At 10 mils, our product wouldn't alligate. There, you wouldn't have any problems. You can spray it thinner than that. It will cure quite well in a thin film because that surface doesn't have any air inhibition. So you've got an insurance policy that it won't. Not that you can't make it alligator, just it's less likely to.
Yeah, you can't. Yeah, you can certainly make it do that if you are really trying. Although, like you said, Jody, sometimes when you're really trying to make something happen for demonstration purposes, it doesn't go that way. So,
yeah.
One thing I do want to clarify is that you know, when we're talking about alligatoring in a thin film and we're talking about between coats, you know, the words coats, passes, layers, they all tend to get tossed around as different things. Generally speaking, Jody, when you're talking about a coat, you're talking about two distinct times of passing material. So you might build up 10 mils with 2 or 3 passes and then wait and build up more. Am I tracking correctly?
Correct. And that's exactly the case most of the time. Sometimes if you're doing really large parts, if you're doing a big boat deck or boat hull, you may not, and it's 90 degrees out, that gel coat doesn't, or our product isn't going to sit there very long before it starts to cure. So you have to try and keep a wet edge the whole time. If you just walk around the whole thing, you're going to come back and probably get something like this, where you've walked around this 24-foot hull and it took you 45 minutes to get back to this point, and it's starting to cure. And as you start spraying on that first pass you put on there, you might get something that looks like this. So keeping a wet edge, moving quickly, keeping in mind that you want to eliminate that semi-cured material there.
Okay. Wonderful. Thank you for that clarification. All right. I know I told you it was the not so fab 5. Those are the 5 most commonly asked questions that we get from a troubleshooting perspective, but there is a sneaky secret number 6, and that is shelf life. And so if you happen to be one of our distribution partners, whether you're in purchasing or you're in customer service or a rep, and you're joining us on this call, the very first question, and if you're an end use customer, the very first question that you should ask yourself when you're experiencing something a little out of the ordinary with your Duratec products, with your Aqua-Buff products, is how old is this material? And while there are some materials like, you know, your house paint that can kind of sit around and age gracefully with you and still be used, Duratec has a warrant for most Duratec products. There's a warranted shelf life of 6 months. Styrosafe is the same. Aqua-Buff is 1 year. Now, I was specific to use that word warranted. That means during that time, we are the most comfortable and confident that that material is going to perform as it should, as the way we've described in any of our application guides for you during that period of time. We know from a chemistry perspective, we've built this nice little package for you to be a solid performer from the date it was manufactured through those 6 months. It doesn't mean it won't work for you beyond that. We have a lot of customers who will cold store our material a lot. If you're here joining us internationally, a lot of our international distributors, they ship them in refrigerated containers. They put them immediately into refrigeration, and that holds that chemistry in suspension so that that shelf life, or that expected use life, is extended. But this one is one that more often than not, when someone is experiencing a problem, it's because it's outside of shelf life. This particular can happens to be from 2018, if my non-glasses eyes are reading that correctly. I'd like to say that we have phone calls from folks that it's only 7 months old, it's only 8 months old. I talked to a gentleman last week, and his material was 3 years old. He still managed to get it to work, but it was definitely performing a little bit askew. His project was a one-off. He felt comfortable being able to do that. If your material is older than 6 months, that's a perfect opportunity for you to pick up the phone and call us and just ask us about cup testing, so we can kind of walk you through to make sure that the material is in good condition. We don't want your job to be any harder than it needs to be, any more difficult than it needs to be. And this is a good one to just check off the list. Fresh material, best material. All right. So like I mentioned before, those were kind of broad, general troubleshooting pieces. You can experience fisheyes in different Hawkeye products, Duratec products. We're going to kind of jump into the product groupings. So on the Duratec side, we sell sealers, putties, primers, top coats. So we're going to kind of go in that order, and that's kind of a build application order as well. We tend to work that way. We'll talk about Styrosafe. We'll talk about Aqua-Buff as well. we're going to try to capture, again, the more commonly seen. Frankly, we don't see a tremendous amount of issues, but when we see issues, they kind of fall within these bulleted points. So we're going to kind of talk about those. Again, if you have a question or if you've had a different experience, this is a great time to pop in a message or post a question to the Q&A board, and we can try to address what you've seen that might be different than what we're talking about today. So I'm going to start by talking about the Duratec sealers. And the Duratec sealers are actually a pretty darn user-friendly product. So we very rarely get phone calls about troubleshooting this. The most commonly one, and I'm going to kind of jump us out of order, the most common question that we get is related to cure time, that someone has applied the sealer to their, whether it's MDF, whether it's tooling board, whether it's whatever the substrate is, that they were expecting it to cure within a certain period of time, and it has not yet. That is perhaps the most commonly asked, or most consistent trouble that folks have with the sealer, is that cure time. Usually it's a matter of the thickness of the sealer that was applied and or thinness, I should say. The thinner or the lower the amount of material that was used, it's going to take a little bit more time, and the ambient temperature. So all of our testing, if you're reading our technical data sheets, all of our testing is done in a nice temperature controlled lab. That's not reality for the rest of us. So you just have to take into consideration, I happen to be based out of Chicago. We are having a remarkably humid day today. If I was to go out and work in my shop, I know everything is going to take just a little bit more time. So cure time is the most common thing we hear about with the sealers. A couple of other things to just know about, less so much about troubleshooting and more about preventing issues from the beginning. The first one is matching product to substrate. We have 3 sealers. I'll give you information on where to find everything you want to know all about them later. But we have 3 sealers. One is a polyester, one is a vinyl ester, and one is a modified urethane. The urethane sealer is fantastic for any kind of more difficult to work with substrate, particularly oily woods. So your teak, your mahogany, sometimes there's a cedar, a type of cedar that's a little oilier than not. That urethane sealer is purposefully designed to kind of mitigate those oily substances and allow some really solid, rich anchoring. So if you've used, for example, our polyester and you've got an oily wood, you may not get the same kind of saturation and adhesion that you would get from the urethane. So the number one tip we can get you is just to make sure that you match the product to the substrate. Polyesters are great for pretty much everything else, unless your substrate is going to see high temps. So if you're perhaps, making a mold or a tool and you want to start by sealing whatever form you're using, if you're going to pop that in for some post curing and it's going to go above the 180-degree Fahrenheit threshold, then we're going to advocate that you choose the vinyl ester instead, which will tolerate that a little bit better and prevent any kind of gas entrapment or porosity kind of moving up through the structure itself. So matching product to substrate. The other questions we get a lot are spray, brush, roll, whether the sealers need to be sprayed, brushed, or rolled. And the beautiful thing is that that is completely up to you. There's not any particular disadvantages or advantages to one over the other, except that whichever method you use, you just want to make sure that you have thoroughly saturated the surface and you aren't leaving pools of the sealer in any particular area where you might have more left on a certain space of the surface than another. The sealer, all 3 of those sealers are pretty low in viscosity, almost but not quite water thin. And so they really, whatever you're using, they really soak down and saturate that surface. And then they leave a teeny little film on top, and that film is what allows you to have really spectacular adhesion with whatever you're putting onto it next. So those are the troubleshooting tips that we would have for our sealers. All right. When we talk about our putties, Jody, our putties are our vinyl ester mold repair putties and our polyester repair putties? What do we see in that world?
Well, I would say these are, we very rarely have any issues with these products, and troubleshooting. I can't say that I've ever answered many phone calls with people asking about problems they've had with putties, but there's some things that will make your life much easier if you know about them and can adjust the putty to how you exactly want to use it. Because in the can, our putties have a rather high viscosity. If you made a golf ball sized wad of it and threw it at the ceiling, it would stick. Now, that isn't always the right viscosity you want for a project. So you can add tooling gel coat to it. You can add normal gel coat to it. You can even add resin to it. They will blend right in, no problem. It's fully compatible, and it will still work with the BPO hardener if you want to use that product. Our putties also work with, and our mold repair putties are BPO compatible and MEKP compatible. The polyester putties that are made from the same type of base as the primers, so they can be used in conjunction with the primers, those are polyester. You need the MEKP to catalyze those, but for the most part out there, it's our mold repair putties that's in the marketplace, and you can go either way. I would say 90% of the time I use MEKP with it. It works just fine. In the lab, you can tell the difference in cure because the BPO paste cream hardener tends to cure better in a thin film. So if you spread the material thinly and you want it to cure quickly, that's why BPO really comes into play. Now, it's the same reason in body fillers that they use BPO, because it will cure fast and it get a good thin cure film, thin film cure, I should say. So that works. Now, once you've reduced the viscosity a bit, you get a couple of advantages. As you stir it, and if it's thick, you possibly, and if you've used our tinted versions or tint it with gel coat, you can hide some air bubbles in there. If you're trying to fill some, rebuild a radius or fill some spots in a mold quickly, and you put our product in there and it cures, and you go to sand it down and you sand into an air bubble, it's like, oh, dang, now I got to refill it and go through the whole process again to fill this little one spot. If you use the untinted version, you can see some of those air bubbles and work them out before they become a problem. So I like using the untinted version in tooling. It really doesn't make that much difference. Some people like to make the repair match. Some people don't care. So you can go either way on that. There's no right or wrong. But lowering the viscosity a little bit with some tooling gel coat or resin, if you don't want it to be colored up a bit, will allow you to see the air and work it out of it a little bit easier. Shrink, it will shrink. It's like any other vinyl ester or polyester. There will be a little shrink. Sometimes I will let it shrink the first time real quick and just mix up a little bit more and skim over the surface. Now you've pretty much compensated for all that shrink, or you can just leave the surface a little proud, a little bit high, and sand it down. The gel time of this product is, 12 minutes or so to, what's that? Oh, I thought I heard somebody say so. It's about 12 minutes or so to when you can sand it. So just depending on ambient temperature, it will start to gel in just a few minutes. So it's, even if you have to repair something, it's not going to take very long to do it. But if you have any more questions about that product, just type them in and we'll answer them later.
Jody, do you feel like because that's a pretty common parlor trick that we do when we're doing mold repair schools on site with customers, is that we'll blend in, like, as you said, some of the tooling gel coat. Sometimes it's one of the other Duratec products that happens to be on hand, and reduce that viscosity. Do you find that the likelihood of shrink changes once that viscosity is lowered a little bit?
I really haven't noticed it because you're not putting in enough to really make a huge change in the product. The viscosity will drop. And if there was a difference, you might be able to measure it in the lab if we did any testing on that. But in the field, everything you do is different every time. So you may not be able to identify it as easily if it does shrink at a different rate.
Okay. And is there any correlation between the depth of what we might see, like in terms of if we're filling a larger gouge or a larger hole than regular than not, and we're using more, is there a more likelihood of shrinkage than if it's a thin?
Yeah, the deeper the hole is that you're filling and the hotter the material gets, the more it's going to shrink. In those situations, you might want to apply 2 layers or 3 layers, depending on how big of a defect you're filling. We don't recommend doing a tremendous amount of filling with this product. You're mostly repairing surface defects or things that just go down into the skin of it. You're not trying to rebuild the tool with this product. It's not really a structural product, although it is quite strong. And you can get a buff it and sand and buff it and get a high gloss on the surface. It's not designed to be structural and fix your mold because you broke it in half, or it's got a half-inch deep gouge in it and you just want to fill it. You might be able to fill a half-inch deep gouge with it, but you would need a couple of layers of it and a little more attention to get that done.
Okay, good to know.
And another thing, hold on for a second there. Mixing it on the cure end of it, we recommend 3% on the BPO hardener that comes with it. We recommend 2% with the MEKP. One of these very low cost Amazon scales that range from $10 to $15 will be your friend, because you want to make sure that you get enough catalyst, enough hardener in there to get a good thorough cure. If you over catalyze it or under catalyze it or guess, and it's very difficult to catalyze small batches of material. So when you have a better chance if you're using a scale when you're using small amounts, and less than 50 grams is very difficult to measure accurately, even with a scale. So in the lab in QC, we do 100 grams at a time. Now, you're not going to probably want to do that. If you go to 50, that's pretty good, but you can't guess at 50. If you're just putting drops in, or this looks like enough, you might not get there. It's pretty forgiving. It's going to get hard, but you may not get the best physical properties compared to accurate catalyzation.
Wonderful, thank you. So as we kind of move up, if we were doing, we're using a lot of language related to mold repair because we're coming off of our putties, but if you're kind of moving up the application, if you put on some putty, then your next step is going to be the primers. Rob, you want to talk us through? We've got a few, and again, folks, if you can't really see we've tried to zoom in, we've tried to differentiate these a little bit, and this will be true both with the primer examples and with the top coats. Just remember that when you get this, you can pause this and kind of zoom in and be able to look at it. Sometimes troubleshooting pictures are tough. So Rob, take us through some of what we see on the primer side.
Well, what you're seeing on the pictures that are on your screen right there, we can start with the first one, which is surface cracks. Most common reasons that you would get this would be you're looking at thickness of material. If you get material on there too heavy, too fast, what happens is as it's starting to go through its gel to cure stage, you're getting some shrink in there because the solvent is now evaporating out of that part. When you get that shrink, you could start to see some surface cracks in there because there's just too much material on there. It went down too heavy. Those can be from stress-related cracks because possibly in your airlines, you got some moisture that built up in there. So it's affecting the integrity of that material that's been sprayed down on there. And that can cause some surface cracks in there. You get some thick, thin areas in there where your thick areas are gelling faster than your thin areas in there, and it's starting to pull that thin area there, and it's going in two different directions, and that could actually open it up a little bit and give you some of those hairline cracks that you would see in there. We already talked about the stress related part of that. That could be moving that part around before it's completely cured and bonded down. It gets bounced a little bit depending on the floor. You hit something into it, that can create cracks in there. Extreme temperatures can affect that. If it's extremely hot out there and that material has actually gone down there, you'll see this a lot in your radius areas where you may have gotten a little bit heavier than on a flat surface, and it's extremely hot, and that goes off so fast that it didn't have time to actually gel and cure properly, and it can crack in those areas as well. The ways you have to fix that is you come back in there, you're going to have to sand that affected area down. You're going to have to remove all that damaged surface coating that you have on there. And you come back in there, you sand that down, remove everything that's off of there. You want to feather it out to the edge, come back with your material again, respray over the top of that, sand it down till you get a nice smooth surface. And then you come back, you buff it out, and you're ready to recoat it. The second picture you're looking in the middle there, the darker picture, those are dimples. Again, you may not see the cracking, but with dimples, that could be because you're getting a rapid film buildup on there. And it also can be because you've got oil, dirt, or some type of solvent contamination that actually got in your airline that can create dimples on the part. So it could be improper catalyzation, or it could be you're using the wrong catalyst that's not required with the specific product that you're spraying with. So we've seen a lot of catalyst absorption in there where the catalyst, you get a little bit of leftover catalyst because you've over catalyzed on that part. It doesn't get absorbed into the material as it goes through its cure. And you could end up with seeing some dimples on there. And again, that comes down to repair that, you're going to have to sand it down, get it as smooth as possible. Sometimes you can sand it out and you're ready to go because it comes out smooth as possible. Other times, if it's too thin in those dimpled areas, you're going to have to go back over the top, respray it again until you get a nice smooth finish. With everything else, it's take your time and you should be all right. The final picture that you see on the end there, and one of the more common that we get calls on that you'll see, is blisters. If you look at the scientific reason for blisters, they'll call it that it's osmotic pressure. And what we call it typically, it's just gassing below the surface. That's what it is. You're getting multiple layers on there. You're getting a layer that's got some excess catalyst in there or some solvent in there. It's gassing off. It doesn't come completely through that top surface, and it creates those bubbles in there. You can also get that from moisture. And like I said, you can get that from excess catalyst that did not get absorbed in there. You can always tell when it's a catalyst blister. You pop that thing open and it's got this acid smell to it, and it's got a mustard look all around the edges on there. And then that's when you'll know it was catalyst. Same thing with those. You're going to have to sand through those, get back down till you've got them completely out. Come back in there. If it's in your primer, then you're just going to take it down. You may not want to take it to all the way down to a 400 because it's a primer. You're going to spray over the top of that anyway, unless you're using that primer finish for your plug or your mold, and you're not going to put a top coat over that. But you want to sand that down to the point where you can come back, feather it, respray it until you get a nice smooth surface. Delamination, we kind of already talked about this earlier. Now you're seeing the picture of it, and it's the same thing. We can go back and talk about it again, but basically that can be from moisture migrating underneath the surface on that part. That could be from that part gets moved too soon before it's completely bonded down. Again, one way to resolve having a delaminated part is you put a sealer over that substrate before you come back with your primer. In this picture here, what you're looking at is a top coat that's sprayed over the top of a primer. And for a reason, whether it was too thick, too fast, or you got solvent that was the wrong solvent, dirty solvent, oil or something that got in the airline and got below that surface between the substrates, and it just made it easy for that to peel right off on there.
Just in
Chunky
that one
filler.
spot, just that one spot.
Yep. And we get that all the time where it could be a 40-foot hole and they buff the whole thing out and they get one radius area or one area in a chime and it pops right off. No explanation for it. Something just got on there that contaminated between the layers. Something happened. I've seen it where in the summertime, guys are wearing those Tyvek suits. They've got to turn their arm to spray over that part. Sweat drips out from underneath that Tyvek suit. They don't catch it and they spray right over the top of it. And then you end up with the DLAM. So there's, like I said, multiple reasons.
Sweat is not a solvent we're adding to the formula here.
Yeah, exactly.
Yeah.
So final picture you're looking at, chunky filler. The most common reason for that is, as we just talked about earlier, that we got a phone call on, material just ages out. The solvent's evaporating out of there and it gets chunky. We actually get a lot of calls because a lot of our primers have a high filler content in there. And the filler, because it's lighter, floats to the top. Your resins and your solvents will float down to the bottom. People open that can and the first thing they say is there's something wrong with the material. They try to get in there with a common wooden paint stir. Not going to happen, folks. You got to get in there. You can put it on a high volume shaker machine, could do it, but 9 times out of 10, what we say, and I just had this call last week, guy stood there and he was turning, he put it on a shaker, came back with a paint stir, stirred it up and kept telling me the same thing, couldn't get all the chunks out. Went and got a cordless drill, put one of those mini paint mixers on the end of it, mixed it for about 5 minutes, material is fine. So other things I tell customers too, if you know ahead of time that you're going to be spraying this material and it's been sitting for a long time, flip the cans off, make sure they're sealed, flip the cans over, let them sit for overnight, slip for a few hours, let that resin kind of seep back down into the filler. It'll make things a lot easier to agitate and to mix back into a common solution that will spray for you.
I think we are all incredibly sympathetic when we see a situation like this. We all understand why something that looks like this might cause concern. And so, as Rob mentioned, we hear about this. Our customer service team, a couple of them are on our webinar with us today, and I'm sure they're nodding along voraciously because this is very common. It is okay to be alarmed by this and okay to call us so that we can walk you through, because oftentimes you can get it mixed back in. This particular one in our image was not going to mix back in, but particularly Styroshield, which is the EPS friendly primer. That one usually has a nice solid layer of filler up at the top, and it can really throw someone off. So we understand if you're concerned. We also understand that it's probably fine to use it. We'll talk you through it. So.
And one other comment on that chunky stuff is the shelf life is 6 months, but if you've opened the can and you live in Arizona and it's 115 degrees for a month straight, you're probably going to have chunks. The clock starts ticking a lot faster once you've opened the can. So the better sealed it is and the cooler you keep the material stored, the longer it's going to last.
Yeah.
But if you open it day one and you're in Arizona and in 6 months you want to use it again, you probably will be disappointed. So never order more than you need. It's sold in smaller container sizes just for that purpose. You only need to open a gallon or so at a time. Don't open a pail. Some customers use drums. You probably don't want to use drums unless you're going through drums really fast.
Fair point, Jody. Fair point. All right. Thank you, Rob. Jody, will you take us to the next level? We're moving our way up through our build, and now we're on the top coats. Actually, I'm going to, before I let you get going, just for the attendees, I know we're coming up on our 1 hour mark. If you need to leave us at any point, we completely understand. We're going to talk about Topcoats. We're going to talk about Aqua-Buff. We're going to open it up for questions and answers. We hope you can hang out with us. We understand if you cannot, the webinar will get emailed out to you so you can catch up on anything that you've left out. So Jody, take us to that beautiful high gloss, blustery shine of a Topcoat.
Okay, the pictures there, one is porosity and the others is fisheye, craters, things like that. On carbon parts, there's so many defects in a carbon part because the carbon fibers are so small and bundled so tightly together that the resin used to build the part has a very difficult time saturating and finding its way through and wetting out all of those fibers. So it will have inherent defects in the surface. So if you're post applying our product onto a carbon fiber part, you will probably have defects in the surface. There's ways to get around that. Sometimes spraying a light coat, several light coats, and then kind of a flood coat can get you past that point. Other times you may have to spray some on the surface and brush it around or squeegee it around a little bit to fill those pits. In the post application, the worst case scenario is even if you've done that and it doesn't all level and flow out again, it's still not that bad of a situation because you don't always need to sand and polish the products, but sanding and polishing gets, if you've made the surface uneven by some type of a touch-up method, you can sand it and polish it and make it look great. Nobody's gonna see it. So, but usually these kind of fish eyes are from defects in the surface. Now, when you use them in mold or you're trying to refinish something that's large, as say a big mold that's existing, and this is a controversial part because everybody loves to wash something down with acetone before they spray it. If you're doing a 1 foot square, you can wash it down with acetone and wipe the acetone up easily or somewhat easily with a clean rag. You have an acetone soaked rag, you wipe the surface and immediately wipe it with a dry clean rag to absorb all of that acetone and the contaminants that it dissolved. If you get, it doesn't scale up well. If you're just wiping the surface with acetone and it's drying, all you're doing is spreading the contaminants around the surface. You're better off not touching it. That's the controversial part. And what I do most of the time, and I did a lot of refinishing over the decades of very, very large outdoor things, and I would sweep or vacuum the surface. I would not spray it down with air typically because you don't know what's in the air. I didn't wash it down with water because you can't always trust what's in the water locally. Sweeping it and vacuuming it were what I did. Any dust that's on there, if this is a polyester part or vinyl ester part that you're making, or even epoxy part, when you spray it on the surface, if it's a very thin layer, it's not a problem. It's just absorbed into the material. It typically doesn't cause anything. On the first couple of passes, you might see that little bit of dust, but by the time you build up the coating to the right thickness, you're probably not leaving dust particles on it that are 10 mils or 20 mils in diameter. So it's just a fine layer of dust. The other thing that acetone does that really can complicate things is when you wipe a surface, and it's really very noticeable on a dark surface, you wipe the surface with an acetone rag and you can see streaks on the surface. That's all of the dust particles that it collected and then deposited in the bottom of the scratches, and it dries in there like mud at the bottom of a dry lake. And now you've got this layer of dry dust in the bottom of these scratches that you just hit this thing with 80 grit to make it bond well. But now the top coat or whatever you spray over it can't get into the bottom of those scratches. So the bond isn't that good. And it can create fish eyes from contaminants. So if you can't use the proper type of solvent used for prep work in the automotive industry and use two rags, one to wipe the surface down, the other to wipe up the still wet solvent that has absorbed all the contaminants, then skip that step. Clean it the best you can with a broom, vacuum it up, do what you can to get it off of there, and go for it. You will probably be better off. We get lots of phone calls where people just smear contaminants around on the surface. So those are two things. Now,
well, I have to chuckle a little bit, Jody, because you did frame this as controversial. And first of all, it's no, it's no surprise that you're ready to delve into controversial areas, but you'd be surprised at how fervent people feel about their acetone wipe after as part of their cleanup. So it does end up being a very controversial stance to take.
now, yeah, again, if you're just doing small repairs, probably not a problem. You can wipe up that acetone while it's still wet, or wash the surface enough times to get it clean. But if you're doing a 24-foot boat hull, it doesn't scale up easily, especially the warmer it gets. There's times when, even on a small surface, you wipe that acetone rag across it and it's dry almost instantly. And in those cases, all you did was spread the acetone's a great solvent, and it will dissolve those contaminants and then spread them across the surface. So just remember that. Another, it goes back to the difference between our products and automotive paints and gel coat. We're someplace in between in viscosity and spray technique. If you have an automotive person spray our products, they have a very difficult time because they want to over atomize the material and they want to turn it into a fog and have it lay down on the surface. It won't lay down well and it won't cover well if that's all you do. You're going to have a tough time getting it down, and it's not going to work well. This goes with our primers too. And if you're a gel coater, you're used to using a great big tip and hosing it on, and you're used to being able to put basically 10 to 15 mils on in one pass. Not that you're supposed to, but it happens and it doesn't sag. And you build it up to 25 mils, no problems, it doesn't sag. Now you've got a product that if you put it on at 10 to 15 mils in one pass, it's going to sag. So you have to build it up a little slower, use the right tip size. All those knobs on the gun are made to be turned. If you're not getting the result you want, turn the knobs. More material, less material, more atomization pressure, less atomization pressure. The products like to be sprayed with relatively low line pressure, 30, 40 PSI. Not that it's not critical, but someplace in there. If you go to 50, no problem. But the atomization air is more critical. Some people want to vaporize the product and just make a cloud. It doesn't work well that way. You want it to be wet on the surface and let it flow together. And that means getting more material on the surface and atomize the droplets lightly larger than what they do in automotive, which can be tough to do if somebody's just 20 years of automotive spraying and they pick up our product and try and spray it. But those are some of the biggest troubleshooting things. Cure typically is fine, and in high humidity areas, the surface cure is going to be slower. One of the things that every person in the industry is going to run into is gel times. These products come with a 15 to 20 minute gel time, right in that range. That could be great if the temperature is 70 degrees, and it could be a nightmare if it's 100 degrees. And lots of the country, and it's getting warmer all the time, is they under catalyze to have a long enough gel time. We make products for this purpose. Our gel time extender or pot life extender goes by Gel-X. That product's available. There's a different ad for each product. It goes into 2% into the polyesters, 0.5% into the vinyl esters. It will about double your pot life. So that works out well. You can also use blended catalyst, CHP. Now you've eliminated any foaming that you might have to eliminate the porosity in this picture, and you've extended your gel time out. And those blended catalysts or the straight CHP tend to give you better physical properties in your cured material, even though they do cure a bit slower. So those are some options. Those are probably the biggest things we run into. Stir it thoroughly. Again, use a drill mixer, because there can be some material in the bottom of the can that you didn't get out and get blended in correctly. It's not as big a problem with top coats, but it's always best to spray it.
So Jody,
Jody,
one of the things that I think is tough when we're doing these slides is that because we all visualize things differently, it's hard to differentiate between what we're seeing. And so I love that so much of your advice is like, let's just get rid of the potential of the problem. We're going to talk through all of the tips for avoiding the problems so that we're not dealing with this. I just want to toggle between, it was hard for us to find slides that would differentiate. So I know I have to put on my readers for this one. Allie, will you so on our screen right now, we're seeing porosity on, at least for me, on the right-hand side. It looks a little bit like a galaxy. Allie, will you toggle back to the oh, you read my mind. Thank you. Back to the pre-release. This also looks a little bit like a galaxy, but Jody, will you help us understand what might be seen differently in a pre-release versus a porosity?
Yeah, and it's really tough to get some of these in a picture, and sometimes it just doesn't show up. It can be really difficult. But pre-release usually shows up as an uneven surface, and it's typically near a radius or something like that. And you may have a reduced gloss in the part that you've made, and some wrinkles in an area, maybe some shrink. So that's where the pre-release comes into play. The surface just comes loose from the mold surface. The material you sprayed on comes loose at some point after you've sprayed it. It gets hard or fairly hard. It comes loose from the surface. It might be during just sitting there. The mold might be being bounced around, or it's when you're putting fabric down and laminating on it and the laminate starts to shrink, you can pull it loose. So that's what you run into. It's kind of hard to see on this one. Now on the fabric one, what you're seeing in this one, and I'll put my spectacles on so I can verify, what you're seeing there is some dry fiber. That is air that is in the fiber. You may not see it when you first pull the part off. We get calls frequently that I didn't see it when I first pulled the part off, but then I put it out in the sun, or I post-cured it, or I did this, or I did that. And now 2 days later, I see some of this white in there. What that is, it's air that was still left in the fabric, wasn't fully saturated, and as everything cured, it heats that air up, starts to swell it. Now it's got to do something, and it moves, and the direction of least resistance is to the surface where the coating is, not into the laminate where the rest of the carbon is, and that sort of thing. So it will move, and now it's visible. And that's what you need to pick the right resins, pick the right flow through your part, make sure that the fabric is being thoroughly saturated. And it takes some experimentation, because every time you make a different part or add a layer or anything you do, it will change how the resin flows. And you may see something like this, and it's like, well, we didn't really change anything. Well, we did. We got a different batch of material. Sometimes different batches of material, the weave is tighter, the bundles are packed tighter, things like that. Different brands do it differently. So what worked on one brand doesn't work on the next brand. And it shows up like this. There's nothing you can do on the coating end to resolve that problem. This is something on the actual lamination end and wetting out the fabric.
Yeah. I feel like we've seen that as Sunshield has become more and more a popular product for infusing with, for a variety of different infusion projects. I feel like we see that one on a more regular basis.
And to add to that, we actually have in mold versions of all these products now, so that people use them in mold over the top of semi-permanent mold releases and have fewer problems with fish eyes. The old versions were made to spray, mostly post applied in the beginning, and they had a much lower viscosity, and they were made to level and flow fantastically, and you could get a really nice finish on it. In mold, you're not worrying so much about that. You want to get it in there at the right thickness, which really 8 mils, if you're using epoxy, 8 mils is plenty. With polyesters and everything, you might want to go to 10 mils, but you don't need our coatings to be thick. There are cases where you want it thicker, but there's cases where you don't. So there's no right or wrong on that part. Typically on clears, you want them thin. On weight sensitive parts, you want it thin. On tooling, you may want it thicker because you know in the future you're going to be buffing and sanding, repairing, and you don't want to run out of surface material there and sand through.
Yeah, very, very fair point. Speaking of, Jody, that's such a great segue because we are hoping that you've made it through your entire Duratec Styrosafe application, whatever it may be. You've got your absolutely beautiful laminate part, whatever it happens to be, and now you're going to buff it. So Rob, take us through just a couple of things that we see on the Aqua-Buff side.
Well, one, and we get this call a lot. You actually had one earlier today, and you can see it up on your screen with the dry residue. The particular problem that came up today was this material is a concentrate. A little bit goes a very long way. If you add misting it and put water on it, you got to keep this material wet. The call today was that it was very dry residue on the part and he couldn't get it to spread. Reason being, he didn't know he was supposed to add water to it. He was using a straight Aqua-Buff.
Yep.
You can take about a quarter size of this material, spray your pad, spray your material, and you'll go about probably a 3-foot square section on that quarter amount of material. It will go a long way. So, and you don't want to leave it on there for very long. You want to take that material, you get it on, you get it wet, you get it buffing, and you want to get it off. We've had calls before too on a very hot day, a part that's been outside, the sun beating down on it, so that part's very hot. Someone puts the material on there a little bit more than they should, walked away for a little bit, maybe went and got their buffing pad, maybe went and got their gun, whatever they're doing, came back in on there, and it was like trying to remove concrete because it got very hard, very fast. And believe me, once it's on there and it dries out, it will bond to that part and will be very difficult to get it back off. The hazy surface, a lot of times what's causing that is the fact that you get a lot of buildup on the pad. Your part looks good, looks like it's finished. You walk away from it, you come back an hour or two later, and all of a sudden it's got this cloudy haze on the part. That's just because you got a little too much buildup. You did not get it all removed. While it's wet, it still gives you that nice gloss finish. Once it completely dries out, then all of a sudden you've got that hazy surface on there. That's kind of the same thing with the low luster gloss finish. You just get too much buildup on there. Once it starts to dry out, it just doesn't look like it's got the shine that you thought you had when you walked away from it originally. Another reason you could get that, as we said earlier, the Aqua-Buff, the shelf life on that is 1 year. We see material out there that's got 2, 3, 4-year-old Aqua-Buff that's sitting out there. Somebody buys a 5-gallon pail. They don't realize they only need a very small amount, so that pail's being opened and closed 1,000 times, sits around for a long time. Next thing you know, it's been back there for 4 years, and it just doesn't give you the finish that you're looking for because it's just really aged out.
I would just add that I feel like what I've seen a lot too, Rob, is the low luster comes from someone, particularly with Aqua-Buff 2000, not switching up their pad. And so if someone's still running it with a wool pad or even a a cotton pad, and they're not moving to a foam pad for shine, that will usually change that up for them.
The key with the 2000 is that it's both. It's a compound to take out the minor scratches and minor blemishes, and it's also a polish.
Yeah.
So to get best results, if you're using it as a compound, you put on that wool buffing pad. You're using it as a polish, then you want to switch that pad out and come back with your foam pad that's an actual polishing pad, and that will give you that high shine that you're looking to finish with.
Perfect. Perfect. So we've walked you guys through kind of the top to bottom, start to finish of applying Duratec materials and a few of the troubleshooting techniques that we hope you never have to use them. As Jody and Rob have both done a great job of giving you preventative tips, we hope that those are useful for you and you don't ever experience any kind of trouble. We haven't had any questions come in, which means you guys are, you're experts. Or it means you're going to sit and think about it for a little bit, and then you're going to reach out to us. So we're going to just talk through some of the resources that we try to have at your fingertips, and then how to get a hold of us. Allison, a few years ago now, redesigned our website completely, including all of our documentation. So if you visit our website, you will eventually find this webinar. You will also find our technical data sheets, which include all of the typical technical data. As you can see, this is a quick leveling top coat data sheet. You've got your product properties, you've got your uses, all of that jazz. And if you kept reading that technical data sheet, it would have a use guide that walks you through a general use application. And in keeping with our theme today, it will have the most common issues experienced with that product and the ways that you can avoid or adapt to them. So there's always a troubleshooting guide at the very end of every tech data sheet. We also have broad application guides. So those application guides on the technical data sheets are product specific. We also have process specific application guides. So if you are resurfacing a mold and you're going to work through several products, it walks you through the choice of those products all the way through the use of all of them for that process. So our website is a tremendous resource for you. As are we. Obviously, we're here with you today. We want you to feel comfortable and confident both with us and our materials. So we try to make ourselves as available as possible. If you're a distribution sales rep, you should have our names and numbers saved. If not, please do so. You'll find our contact information there on the screen above. Obviously, we enjoy talking about our products. We love being able to find solutions and save you guys time, energy, and get to a finished product that you are proud of and that has taken as little time as possible. So it's our goal to help you identify those issues or avoid those issues, solve those issues, and then certainly make product selection recommendations as you're exploring any kind of change in your process. So please feel free to put our contact information down. Also, our customer service team, they monitor our website, our Instagram, our Facebook, as does Allison, our marketing specialist. So we've got a whole team here of people that are ready and willing to help you. So we hope you have found this webinar to be useful. Maybe it filled in a few answers to questions you've had previously, or maybe it gives you the insight and information you need to start a new project. Jody, Rob, do you have anything else to add before we let everyone go?
No, it was a pleasure.
No, I'm good.
Thank you, everybody. And if you need,
Appreciate everybody being on the call.
Yeah.
All right. Reach out to us if you need anything. Thank you all for your time. Take care.
Bye.
Bye,
Bye.
guys.